So we want to learn how to sketch this graph. So get my pen up. Okay, that graph there. Now in the previous lesson, we looked at what the effect of A does. So A either stretches the graph wider or narrower depending on the value of A. And if A is negative, it would reflect the graph. Then we also look at the value of K, so x squared plus K. So K is the number by itself. So when K is positive, it moves the graph up, and when K is negative, it goes down. Okay, so, and then we looked at the graph of y equals x minus h all square, and h either shifts the graph or translate the graph to the right or the left depending on the value of h. Okay, so we are going to combine all three today, and some of the things we're looking out for in this lesson is the turning point. Okay, what is a maximum turning point? What is a minimum turning point? Okay, we've should have seen wider and narrower. We discussed about that, and we are going to look at the x-intercept and the y-intercepts, and we are going to also make a rough sketch. Okay, so if you're having trouble understanding stuff, don't stress. We'll continue working through this next week when we return to class. Okay, so let's look at our first example. So our first example, straight away, I can tell that this graph is going to translate 4 units up. So if we have y equals to x squared like so, so this is y equals to x squared. So I know that this graph here, because of the plus 4, is going to go up 4 units to the in the y direction. So it's going to go 1, 2, 3, 4. It's going to go up, and it might look something like that. Okay, so that's one of the transformation. Okay, so it's gone up, or it's translated 4 units up. And I know that this value here inside the bracket, okay, so remember that's the h. So this here will translate the graph. Don't know why I'm writing this. So it will translate the graph 3 units, okay, in the x direction. Okay, so in the x direction. So what would that look like? So I actually should label my x and y axis. Okay, so make sure you label your x and y. So what's going to happen now is, so we can take this graph over here. So this graph here will now be translated. Okay, 3 units. Maybe I'll get out this error and make it go like this. It will go 3 units that way. Okay, so it's gone up 4 and it's going to move 3 to the right. So it's going to go 2, 3, 4. So now it's going to go 1, 2, 3. So this point here, okay, will now be over here. So it's going to look something like this. Well, that's a bit too wide. Let me make it a bit more now. So it's going to go something like that. Okay, so it's gone 4 units up, and then it's going to go 3 units to the right. Okay, so 4 up and then 3 to the right. Okay, so now we call this point here, so this point, let me use the yellow bit. So this point here, this is called the turning point. It's called the turning point. Okay, so it's a point where the graph starts to turn around. Okay, so so you can see that it's going down, and then it starts to go up. So okay, so it's just a point where the graph starts to turn around. Now there's one thing you might need to know, and that's called the line of symmetry. The line of symmetry basically is a line that cuts the parabola in half. Okay, so I'll write it down here, the line of symmetry. So the line of symmetry, it cuts the parabola in half. Okay, so that means that whatever's on one side of the line of symmetry is just a reflection of what's on the other side. Okay, now next thing we're going to look at is whether this parabola here, so maybe I'll just draw it over here, so whether this parabola, okay, so I just draw it like that, Okay, so this point here is 3, 4. Okay, move 3 units to the right and 4 units up. This is our x, y. Okay, so now the question here is, did it cut through the x-axis? So, well, it doesn't cut through the x-axis, right? It just goes down like that and then went back up. Okay, it didn't go through the x-axis. So that means that there is no x-intercept for this graph, but there is a y-intercept. So the y-intercept is the point at which our parabola cut through the y-axis, which is over here. So this point here is called the y-intercept. Okay. So we want to know what is this coordinate. Okay, what is that coordinate? Well, we know that the x-coordinate is going to be 0 because it starts from 0 here. So the x-coordinate is going to be 0. But what about the y-coordinate? What is that value here? Okay, and we can find that by letting x equal to 0. So remember, when we're sketching linear graphs, to find the y-intercept, we let x equal to 0. So let's do that. So we say y-int let x equals to 0. So that means x here is going to be 0. So let's substitute 0 into where x is. We'll get y equals to 2 times 0 minus 3 square plus 4. So that becomes 2 times, so 0 minus 3 is minus 3, and minus 3 square is 9 plus 4. Okay, so y int is equal to, so that becomes 18. 2 times 9 is 18 plus 4 makes 22. So the y-intercept is at 22. Okay, so I'm going to rub that off. So that becomes 22. Okay, so see my team's flashing. Alright, so maybe I'll talk to him later about that. All right. So coming back. Now, there is no x-intercept in this graph, so that's all we have to do. Now, does this graph have a maximum or minimum? Okay, so when it's, let me come back over here. Okay, so is it a maximum or a minimum? And if you look at the graph, okay, it's essentially, if we have a parabola looking like this, okay, we have a minimum, okay, because we have a minimum y value. Okay, so the smallest y value is 4. Okay, so that's a minimum. And if you have a shape that looks like this, and if you have a shape that looks like this, if your parabola looks something like that, right, then we have a maximum. So you can think of this is the highest point on a hill. Okay, so that's a maximum. Okay, so think of it as the highest point on a hill. Our parabola is a hill. Okay, what is the highest point on the hill? And we call that point the maximum. Okay, and this here is kind of like the lowest point, so we call that a minimum. Okay, so in this graph we have a maximum. Our y-intercept is at 0, 22, so it's 22. There is no x-intercept because the graph did not cut through the x-axis. Okay, so let us look at one more example. Okay, so again, now I mentioned a bit earlier, maybe I didn't, well I'm going to mention it now. So when we are sketching the graph in this form, so in the form y equals to ax minus h squared plus k, okay, this equation, let me just put the square the line of it. So this equation is called the turning point form. Okay, because the turning point is at h comma k. All right, so just let's look back to our previous example. So the turning point is at, okay, it tells you here, right, 3 and 4. So the turning point is 3, 4. So this point here is 3, 4, which is the turning point, okay, 3, 4. So in this example, the turning point would be -2 negative 3. Okay, so negative 2, negative 3. All right, so let's just go through some transformation to demonstrate that. So we start off with our base graph, which is just y equals to x squared. That should be there, touch the origin. Then the graph is translated 2 units to the left, so it goes 1, 2. So now it will look something like this. Okay, so it'll look something like that. Well, that's pretty bad. And then it gets translated 3 units down. So it gets translated 3 units down. So it's going to go 1, 2, 3, and it's going to end up here somewhere. Okay. All right. So it's going to look something like that. The turning point is at negative 2, negative 3. Okay. So now what we need to do is we need to identify the x-intercept. So let's just call this x int, y int. All right, so let's work what the x-intercept is. So similar to finding the x-intercept for linear graphs, we let y equal to 0. So when finding the x-intercept, so x int let y equals to 0. So y, so our equation, this equation here, will become 0 equals to 0.5 x plus 2 squared minus 3. Okay, so now we need to solve for x. Okay, so what I'm going to do is I'm going to plus 3 to both sides. So plus 3 to both sides. So I'll get 3 equals to 0.5 x plus 2 squared. Now I'm going to divide both sides by 0.5, so divided by 0.5 and divided by 0.5. So 3 divided by 0.5, or 3 divided by half, gives me 6. Okay, then I have x plus 2 square. Okay, so now I'm going to square root both sides. So when I'm taking the square root of both sides, I have a plus and minus, remember? So if I have the square root of 100, if I take the square root of 100, I get plus or minus 10. So the answer could be positive 10 or negative 10. Okay, negative 10 times negative 10 gives me 100, and 10 times 10 also gives me 100. So I'm going to take the square root of both sides. So I'll get plus or minus square root of 6 is equal to x plus 2, and then I'm going to subtract 2 to both sides. So x is equal to minus 2 plus or minus root 6. Okay, so that's where the x-intercept is. Okay, now the square root of 6, that's between 2 and 3, it's closer to 2. So now I'm going to draw my graph. I'm going to take out my calculator. So let's clear this up. So I'll do minus 2, minus 2, minus 2. Okay, plus the square root of 6. Square root of 6. Okay, I didn't like that. I'll do square root of 6. 6 square root. Okay, and then minus 2. And that gives me 0.449, which is roughly 0.45. So that's one of my x-intercept. So x-intercept equals minus 2 plus root 6. So the other one is x equals to minus 2 minus root 6. So let me do that. So here we have root 6. Okay, and I'm going to take the negative of that, and then I'm going to minus 2. Okay, and the other x-intercept is at negative 4.449, which is roughly negative 4.45. Alright, so now I'm going to label my x-intercept. So one of them, so let's make that 1 and 2. So that's minus 1, minus 2, minus 3, minus 4, minus 5. So this here is roughly negative 4.5-ish, negative 4.5-ish. So it's around there. Okay, so that's negative 4, that's negative 5. And the other one is right around here. Okay, so that is that there, and that is that there. Okay. Alright, so now I'm going to find my y-intercept. So this is my y-axis and this is my x-axis. So to find my y-intercept, so just going back to my equation, so this is my equation over here. To find my y-intercept, I'm going to let x equal to 0, so let's do that now. So y int let x equals to 0, so y is equal to 0.5 x plus 2 square and plus 4, oh, no, minus 4, I think it was minus 4, no, minus 3, minus 3, minus 3. Okay, now I did say let x equal to 0, so I'm just going to cross that off and make it 0. Okay, so now I get y equals to 0.5 or half. So 0 plus 2 is 2, 2 square is 4. So 4 minus 3. So y equals to a half of 4 is 2. 2 minus 3 is minus 1. So y-intercept is at negative 1. Okay, so the y-intercept is at minus 1, which is about here. So, which is something like that. Okay, so that's minus 1. And now I'm going to put in my turning point. So my turning point is at minus 2 minus 3. So minus 2 minus 3 is my turning point. So minus 2, minus 1, minus 2, minus 3. So minus 2 minus 3 is roughly here. And now I'm going to just join all the coordinates together like so. Okay, so like that, and then it's going to go up like that. Okay, so that is y equals to 0.5 x plus 2 squared minus 3. So that's that equation there. Okay, so we've got the intercepts. Okay, we've got the turning point, which is minus 2 minus 3. And we also got the y-intercept, which is minus 1. Okay, so again this here, okay, so think of it as what is the minimum y value? What's the smallest y value? The smallest y value is minus 3. So this here is a minimum. So, okay, so this here is a minimum turning point. Alright guys, so it's a big one, so rewatch the video and just ask me. Don't stress too much about this. If you don't get it, I will continue with this when we get back, okay?